Hello students, welcome to today's session. In today's session we are going to discuss two topics. One is we are going to discuss recursion as well as we are going to discuss tower of an eye. First, coming for recursion. Recursion is nothing but any function that is calling itself. So we'll have two things. One is a function should call itself. Okay, if it is calling itself, then it is called as a recursive function. And this function should have something called as base condition. So what is base condition is? So this function which will be having a position or a point at which it should stop. It should stop its recursive function call. So recursion is nothing but a function is calling itself again and again is called as recursive function. And this function what you are going to write should have a base condition which will be representing where that calling itself will stop, which is called as base condition. Now we have taken an example called as factorial of a number, so which you have already studied how to find a factorial of a number. Now in this statement or in this function we have integer which represents the return type and fact which is the name of the function, and it is taking a parameter called as integer n, and it is having these statements. So we are going to see how this is going to execute. Now from the main function, if I want to find factorial of some number, say 6, I want to find factorial of 6. If I want to find factorial of 6, n value is nothing but 6. Okay, I want to find factorial of a number, the number is 6. Now in this case, when the function is called, we are going to have the function call as fact of n, which is nothing but fact of 6. So this value or this function will be starting, that is this function starts executing. Once this function starts executing, we are going to have, since this is a recursive function, so we are not going to have only single function call, we will be having multiple function calls. Okay, since we will have multiple function calls, what happens is, so this is the first function call. I'll just list out here. Say the first function call, if I consider, we are talking about the concept called as stack. So how stack is used in a recursive function, that we are going to discuss. Now the first function call was fact of 6. So that I am going to write at the bottom of this stack, which is fact of 6. Okay. So now if I want to find fact of 6, I need to find, once this function is called, I'll get fact of 6. So fact of 6, we are going to check whether n is equals to 0, that is 6 equals to 0, which is false. If 6 is not equal to 0, then we will come to the else section. In the else section, we are going to return writing that n into, we are going to write 5, or that is 6 into, so n value is 6, so we are going to write 6 into fact of n minus 1, that is, I am going to call this function called as fact again with a different value called as 5. Now this is the second function call what we have. So that is, we have fact of 5 here. Okay. So now if I want to find fact of 6, I need to first find fact of 5. So this function call, first function call as entered into stack. Now again we are going to add second function call, which is fact of 5. Okay. Now if you want to execute fact of 5, when this function is called, fact of 5, n value will be 5. So 5 equals to 0, which is false. Again we want to write 5 into fact of n minus 1, which is fact of 4. So I am going to write 5 into fact of 4. When I execute 5 into fact of 4, in this case, so this is the number, I can multiply it, but this is a function call. Now to complete fact of 5, I need to execute fact of 4. So I will call one more function call, that is fact function will be called again with a different value. What is the value? The value is 4. So I am going to get the result something like 4 into fact of 3. So this is the third function call what we have, which is fact of 4. So like that it is going to continue. Say we are going to continue with fact of 3, which will be 3 into fact of 2, and we are going to have fact of 2, which is 2 into fact of 1. So and we have again fact of 1. So when fact of 1 will be called, it will be 1 into fact of 0. Now, in this case, it is going to stop. When it is going to stop? When we have fact of 3, fact of 2, fact of 1. So after fact of 1, if you call fact of 0, it will become 0 into fact of minus 1. Okay. So at this condition, when this function is called, when n value is 0, it is going to return which value? It is going to return 0. So in the case of fact of 1 or fact of 0, you can also write it as fact of 1. Okay. If you want to reduce this, you can also make it as fact of 1. So once I make it as fact of 1, so fact of 1 is called, it is going to return 1. So in the place of fact of 1, I am going to get the value as 1. So we have the function calls like this, that is fact of 1, fact of 3, fact of 2 and fact of 1. So if we have these function calls, now this is called as base condition. This is where the recursive function call will stop. When it will stop? When n reaches 1. So when n reaches 1, this function has completed, where I will get the result as 1. And this value will be used here. So in the fact of 2, where I will get 2 into 1. And again, this value, that is 2 into 1, which is 2, will be used here. Okay. In fact of 3. So this is completed, where I will get the value as 6. And again, we are going to complete this, that is fact of 4 will be completed. We will be multiplying 4 into 6, which is 24. Okay. And again, fact of 5 is completed by multiplying these two values. When I multiply these two values, I will get some value like 120. Right. It's 20 and 12. Yeah. So it is 20, 0, carry 2, and then it is, it is 120. And after that, once I complete fact of 6, it is going to multiply 6 with 7, which is something like 720 or 740. Okay. So it is 0 and 12 to carry. Okay. It is 720. 720 will be the result when I calculate factorial of 6. Okay. So this is how we will be using recursive function. So whenever you execute any recursive function, we are going to use stack. Why? Because we have multiple function calls. These function calls cannot be executed in a single, once the function is completed, I cannot complete this function call. If this function call wants to be completed, I need to execute all these function calls. So for that case, we are going to store those function calls into a stack. And once it reaches the end, we are going to execute one by one. That is last in, first out, last in, first out, last in, first out. So that the last function call will be executed first, and then the second, third, fourth, fifth, and lastly we will get the final result. So this is about what is recursion and how stack is implemented using recursion. So next I am going to continue with the topic called as Tower of Hanoi. So coming to the Tower of Hanoi topic. In Tower of Hanoi topic, so Tower of Hanoi is simply to say it is a mathematical puzzle. It is just a puzzle. Okay. In this puzzle, what you are going to have is you are going to have 3 towers, or it is also called as 3 pegs. Okay. So these 3 pegs, will name it as A, B and C. And also you can consider it as source, auxiliary or destination. You can replace anything here. You can consider one as source and one as destination and another one as auxiliary. We are going to have 3 pegs, which is source, destination as well as auxiliary. On these pegs, we are going to have something called disks. So I will have 2 disks. So and these disks will not be of same size. So each and every disk will be of different size. Disk 1 and disk 2. So we have 2 disks. So the rule is I need to move the disks from source to destination. I should move this disks from source to destination. How to, while moving it from source to destination, we are going to follow a few rules. What are those rules is, first, only one disk is moved at a time. So I cannot take both the disks at the same time. I cannot remove both the disks at the same time and it will be placed at destination. That is not done. So only one disk, that is the first disk, which is topmost disk, will be moved first. So the rule is only one disk can be moved and only the topmost disk can be moved. I cannot take the disk that is below it. Okay, second disk cannot be taken, only the topmost disk will be moved. And the third rule, so you cannot place something like this. If you have a smaller disk, on smaller disk you cannot place the larger disk. Okay, so you should place always a smaller disk will be placed always on the larger disk. You cannot place a larger disk on the smaller disk. Okay, now according to this, I need to by following these three rules, I need to move this two disks from A to C. Okay, how to move it? Say for example, if I have this at the beginning, so I have the first disk and second disk. I have this three pegs, so we have source which is called as A, and auxiliary which is called as B, and we have destination which is called as C. Okay, now if I want to move, I'll move disk 1 from A to B, so I'll get disk 1 here. So disk 1 will be moved from A to B. Then disk 2, first move was what? I am moving from A to B. Okay, next move is I am going to move the disk 2 from A to C. So I'll move disk 2 from A to C. So the disk 2 will be moved to its destination. So we had A to C, which is second move. And third move was from B to C. So we are going to move from B to C. So I'll get something like this, which is this disk from B, it will be moved to C. So we have moved those two disks from source to destination in how many moves? We have moved it in 3 moves. So how to calculate this? So this will be the minimum number of moves. By using minimum number of moves, we should move from source to destination. How to calculate that? By using the formula like 2 to the power of n minus 1. So the number of disks we had was 2, which will be represented by n. So 2 to the power of 2 minus 1, which is nothing but 4 minus 1, we are going to get the result as 3. So within 3 moves, I should be able to move from source to destination. So like that, we will be having 3 disks, 4 disks, and number of disks will increase based on our requirement. And how many number of disks will be, how to calculate the number of moves? Number of moves will be calculated by 2 to the power of n minus 1. If you have 4 disks, it is 2 to the power of 4 minus 1, which is 15 moves. We are going to make 15 moves to move from source to destination when the number of disks is 4. Okay, this is a problem for Tower of Hanoi. Already explained with in the PPT. So now here I have explained with the example. Now the same thing you should try it with 3 disks. Try it for 3 disks and write down the how many moves you have and just send me through your message or mail so that I can check the result. Okay, so and next session I'm going to explain the algorithm as well as program of Tower of Hanoi. Thank you.